Thank you. So my name's Sarah Schwartz, and today I'm going to talk about building Web2-style privacy into Web3. So just to start, a little bit about me. I'm a developer relations engineer, and I started building in Web2, and I think probably like a lot of you, when I started building in Web3, I started with smart contracts and with Solidity. And I sort of had to go through this like mental shift of like how I thought about building. I had a lot of ideas of like, oh wow, this could be a really cool idea for a smart contract. But then finding out later like, oh, there's different constraints, and really hit with this like, nothing is private on Ethereum. I had all these ideas of like, wow, you could make some games that have some privacy on chain, and it's all decentralized. But okay, I had to take a break, reprogram like how I thought about building, and tackle some different ideas that were more in line with this reality here. And so, yeah, basically just sort of breakdown of like switching from Web 2 to Web 3, going from like everything can be private if I want it to be, but nothing is verifiable or trustworthy by external parties, to this like having to trade off. If I want verifiable stuff, it can't be private on chain. And so like what does that sort of stack look like visually? So like this Web 2 builder is super happy. You can fully control every part of the application, but kind of sad no one can verify it, and no one knows I didn't tamper with it. On the other side, now using Web3, like your basic Web3 stack, anyone can verify this data, but it's 100% public. There's a lot of parts of the stack that I don't control, and there's a lot of limitations there. And so where does that leave builders? You sort of have to choose at least one option, from what it seemed like. You have to choose a privacy-focused chain that requires some level of trust in the operators, or you have to basically make everything private, like fully encrypted, even to the devs, so you don't know what's going on. Or you just end up using some Web 2 solution. Right? But what if you want something more like Web 3? What if you're trying to build an application that's a little bit more like Web 2 but have that verifiability? Something where you can make anything private. You can still have full data access for the developers, for analytics, for compliance. You can easily edit what's private without redeploying contracts. And then it still settles on Ethereum, it's interoperable, and you use like standard Solidity contracts. So that's what ZKstack enables, or that's one thing it enables. ZKstack is basically our stack for all chains in the Elastic network. And we really think that builders deserve the option to build anything. And there was a talk about this earlier, but what is the Elastic network? It's basically we're calling it a roll-up cluster, where it's like a bunch of L2s that have like a shared bridge. They're all interoperable with each other. They all use the ZK stack, but they all can be sort of customizable for each chain. So if like one chain wanted it to be, fully private, they could, or like ZKsync era is just a roll-up where everything is public. So this is, basically you can get the best of both worlds here with a ZK app chain that uses a validium and custom RPC proxy. I'm going to get into that a bit later. But yeah, you can have private data, and it's fully verifiable on-chain, composable with Ethereum. And basically, as a developer, you can control the entire stack. You have your own chain that you can customize your contracts, your own RPC proxy layer and authentication layer, and it's all yours. So just to define some of these terms, what's a validium? Essentially, it's like a chain that doesn't post its data on chain. What does that mean? Basically, like all of the data on chain doesn't get to other chains. It doesn't get to Ethereum. It's private. And then what is an RPC proxy? It's essentially like a middleware server that sits between the client applications and the chain node, and that's where the authentication would happen, just like in Web 2. Okay, so what exactly stays private, right? Like, what's the catch? So with Validium chains and ZK stack, only the state root hashes are public. So actually, all of the state and the balances can be fully private. the private balances only become known if they're bridged to a roll-up chain, but they can actually be bridged to another private chain and stay 100% private. Okay, so how do you actually build this? I'm going to go through like a really quick, workshop of like, here's how easy it is. We have this CLI called ZKStack, and it's really easy to install, and it basically is everything you need to like launch this local chain. So you can just run this ZKStack ecosystem create command. It will create basically like a little elastic network on your computer where you can create different chains. And it will ask you some prompts when you're setting it up. This is where the customize part comes in, where you can choose like, okay, here's the chain is called my game chain. I have the chain ID here. I'm setting the data availability as a validium. I can set the base token for different fees, so I could actually make my own ERC20 that I could use for fees on this chain. And then at the end it asks you if you want to start the containers after creating, and those are Docker containers. So once you run this command, you have like some Docker containers running. Basically, this is like your local L1, like Ethereum node, and then a database for your chain. And then one more command to run, which essentially like initializes your chain, and basically just start your server, like local server. So you imagine you have like your Ethereum server and your Validium chain server running right now. And next step is, so like you have, with this local Ethereum node, you have some rich wallets that are already pre-configured on that network. So the next step would be to like bridge some funds over to your chain. So this is just using like these local endpoints here. So our chain's running at localhost 3050, and the L1 is at localhost 8545. And another piece we need is a contract verifier. So this is like another server running basically. So you open up a new terminal and just run these commands, and then you have like your contract verifier set up for your block explorer. And okay, I know this is too small to read, but basically this is what the configuration looks like for when you're deciding like what is private. And this is all like not on chain. This is basically your RPC layer right here, and this is this is not part of ZKStack right here. This is actually a custom implementation done by our friends at Moonson Labs. They're contributors to ZKsync, and they basically just made this sort of config where you can like put in a function. And here, this function I have is like get player boards. This is an example for a sort of like battleship style game that I made like on chain. So you're inputting like the player address and the game ID. It's returning like information about like where the ships are on the board. But you have this sort of like constraints here where you're saying if you're reading this function, it's a read function. Then you have to check the argument at index 0, which if you notice, that's the address player. And essentially, it's just some custom, authentication code here going on to check, like, okay, whoever's calling this function is the player themselves. And yeah, you can basically make up whatever rules you want here. And so to make it public for everyone, just to be able to get like the game ID or number of games someone's played, you can just decide that's public. So none of this is in the smart contract, right? This is all something you can change just in the RPC layer. So if you wanted to, for whatever reason, make this private at some point, that's totally doable without any like loss to your contract state. And then this is sort of like what's happening in the background here is just sort of like the RPC layer is just cycling through these config rules and, like assigning different handlers to the responses. So if it's public, it will create this public rule. If it's this check argument constraint, which we had here, then it will check, essentially like parse that function signature, pull out that argument and check that the argument is equal to the caller. Okay, so like, what does it actually look like on a block explorer? Like, how is this private? So this is the example that Moonsong Labs created. They're called it 00, but essentially like a block explorer where there is this level of authentication. So you have to log in to see any transactions. And here's what the login page looks like. So it's kind of interesting. You can't just connect to the open RPC network. Like that 3050 port we have is fully open, actually, and you wouldn't want to share that because, yeah, anyone can connect. But we have like this other customized RPC URL that generates a token for each user, and then this like provides the authentication for that. So to connect, they get this custom RPC URL with like their token. And then they can connect to MetaMask through that. And then what does it look like on the Block Explorer? So this is showing like two different players playing the battleship game like against each other. Instead of ships, I call them bots or whatever, but you can see like you're starting the game, placing the bots and hacking them. And you can see this contract has 9 transactions total, but each player can only see their own transaction. Because that's what we chose in that privacy config, that like the player has to match, that first argument for those read functions. So yeah, this player can see 4 of the transactions, this one can see 5, and that's all of the transactions for that contract. And the balance of the contract is also like restricted. You'd have to configure like some sort of admin owner or configure access to that as well. All right, so yeah, what are some use cases for this? This is an example of like a private swapping application that Moonsong Labs built. So you can see like some things we do on chain already, but maybe we would just like them to be private. And then this is the sort of like battleship style game I made. It's called Bots Attack. But you can see like there's these other use cases where basically like the use case requires the privacy, right? Like you can't play this game if everyone knows what the opponent's board looks like. It just doesn't work. So yeah, trading apps, games like poker and battleship and other games that require privacy, I think are really good use cases for this. Personal data trackers, banking and exchanges, private subscriptions, social and dating apps, B2B payments. You can imagine all these apps exist today in Web 2, and they're just using, they're using basic Web 2 tech. They want to be able to keep some of that privacy, like for sometimes it's the use case, sometimes it's just about like, okay, this is our data, and we want to be able to do what we want with it. So this sort of, this option basically provides this like middle route where you're like, okay, not a full-on like, Web3 degen where it's like everything's going to be private, like Tornado Cash style, and like there's no one can tamper with it. This is sort of like a middle of the road, like, well, what if you want a little bit of both, and you want to just build something like, whatever you want, and it doesn't have to fit in these tight constraints of like Web 2 or Web 3. So yeah, ZKsync is the end game. I have this QR code and a Linktree link, and this will have like link to all the slides, a full tutorial for like how to build the private chain locally, how to build the bots attack game specifically, and yeah, just more info about ZK Stack. So, yeah, thank you.